Hello everyone. Today we're going to look at the distance formula. If we wanted to find the distance between two numbers, then all we'd have to do is find the absolute value of their difference, so a minus b, and then an absolute value. However, if we want to find the distance between 2 points, we're going to need to use the Pythagorean Theorem. So we have 2 points, x1, y1, and x2, y2. We create a right triangle that's shown in red, and we use the Pythagorean Theorem. So remember, the Pythagorean Theorem says that a squared plus b squared equals c squared, where our legs are a and b and our hypotenuse is c. So what we're really looking for here is c, which we'll call d for distance. So we want to find a squared and b squared. So a, I'm calling the distance along the x-axis. So that is just the difference in the x's. So I'm going to take x2 minus x1. B is the vertical distance, so that is the difference in my y values. Okay, so then we're going to replace those for a and b. And we're going to solve it for, again, d, which is really c. So d is the square root of x2 minus x1 squared plus y2 minus y1 squared. A couple of things to note here. Whenever you square a number, remember that the result is something positive. So even if x2 minus x1 is negative, as soon as I square it, I get a positive number. So this is always a positive plus another positive. Right. So keep that in mind when you're doing out your work. And we'll just do some examples. So find the distance between each pair of points. The first pair is 3, 2 and 0, negative 2. So I'm going to plug them in. I have x2 minus x1. Since I'm squaring it, the order doesn't matter. If I do x1 minus x2 or x2 minus x1, the only difference there is a negative, and then again when I square it, it becomes positive. So I'm taking 3 and 0 and subtracting them, and I'm taking 2 and negative 2 and subtracting them. So 3 minus 0 is 3, and 3 squared is 9. 2 minus negative 2, we have a double negative there, so that's 4, and 4 squared is 16. 9 plus 16 is 25, and that happens to be a perfect square. So the distance between the 2 points is 5, and then there'd be some unit associated with it, feet, meters, inches, whatever it is. Remember, it's a distance. Let's try another one. So let's find the distance between -1, -3, and 0, 2. So now I'm going to plug them into the formula. Just make sure your x's are in the same thing and your y's are in the same thing, and that you're subtracting one of them. So -1 minus 0, -3 minus 2. -1 minus 0 is -1. -1 squared is +1. -3 minus 2 is -5. -5 squared is 25. So I have the square root of 1 plus 25, which is the square root of 26, which is not a perfect square. So in this case here, I'm just going to round to the nearest tenth. So I plug it into my calculator, and I get about 5.1, which hopefully makes sense. We know the square root of 25 is 5, so it should be a little bit bigger than 5. How about the distance between the points 30, -15, and -10, -10? So again, I have 30 minus -10, and I have -15 minus -10. So both of those are minusing a -10, which is the same as adding 10. So for the first one, 30 plus 10 is 40. 40 squared is 1600. -15 plus 10 is -5. And -5 squared is our 25. That's a negative. So we get the square root of 1625. Again, that's not a perfect square, so we're just going to round to the nearest tenth. And we get it's roughly 40.3. And as our last one, we have the points 2, 7 and negative 3, 19. So d is the square root of 2 minus negative 3 squared plus 7 minus 19 squared. 2 minus negative 3 is 5. 5 squared is 25. 7 minus 19 is negative 12. Negative 12 squared is 144. Add them together, and we get the square root of 169. That is a perfect square. It's 13. Okay, so sometimes you'll get integers, sometimes you won't. So depending on the problem, it might ask you to round to a certain number of digits. It might ask you to leave it. So just make sure that you read the directions carefully. Okay, so read through the book and let me know if you have any questions. Thanks.